Enlargement. An enlargement is the only transformation that changes the size of a shape. Enlargement is increasing the size of an object or figure. Two items of information are needed to enlarge a shape: the scale factor and the center of enlargement. The scale factor indicates how many times a given object increases its size. Center of enlargement is a fixed point inside or outside the shape to expand. Now I will show you how enlargements can be represented by matrices. We use the same steps as the reflections and rotations. Enlargement by a scale factor of k with a center of enlargement at origin. Select the points 1, 0 and 0, 1. Look at the diagram. Find the image of these points under the given transformation you want to. We want to increase the size of the shape. Then we increase the size of x coordinate and y coordinate. Write down the position vectors of these images. 1, 0 turns k 0. 0, 1 turns 0k. The position vector of the image of the first point becomes the first column, and the position vector of the image of the second point is the second column of the required matrix. This is the transformation matrix by enlargement by a scale factor of k. When multiplying by this matrix, the point matrix is enlarged by a factor of k in the x and y directions. Two features of the scale factor you must keep in mind. If k is greater than 1, the image figure is an enlargement of the shape. If k is between 0 and 1, the image figure is a reduction of the shape. Let's see how it works. Example. Consider the triangle ABC with vertices A, B, and C. Find the position of the image of triangle ABC. Find the position of the image of triangle ABC under an enlargement with center of origin and scale factor k equals 2. We take the transformation matrix and left multiply it by the shape matrix of triangle ABC. The result is a matrix of coordinates of the resulting shape after the transformation is applied. The image points are then drawn on the diagram, and we get the image of triangle ABC. Find the position of the image of triangle ABC under an enlargement with center origin and scale factor k equals 1/2. We will make the same, but now the scale factor is greater than 0 and less than 1. Then the enlarged shape will be smaller than the original shape. Take the transformation matrix and left multiplied by the shape matrix of triangle ABC. Stretch. In a stretch, we enlarge or reduce an object in one direction only. We only consider stretches along the x-axis and y-axis. In this example, the rectangle has been stretched to give another rectangle. The points on the x-axis have not moved, so the x-axis is called the invariant line. The invariant line is so named because any point along it will not move under stretch. Look at this new example. The rectangle has been stretched and now the points on the y-axis have not moved. So the y-axis is called the invariant line. As stretches are enlargements in one direction, let's take the transformation matrix for enlargement to get the transformation matrix for stretches. Stretch with invariant y-axis. A stretch with scale factor k parallel to the x-axis leaves the y-axis unchanged, and the transformation matrix is given by. When multiplying by this matrix, the x-coordinate is enlarged by a factor of k, whilst the y-coordinate is unchanged. Let's see how it works. Consider the triangle ABC with vertices A, B, and C. Find the position of the image of triangle ABC. Under a stretch with invariant y-axis and scale factor k equals 3. We take the transformation matrix and left multiplied by the shape matrix of triangle ABC to get the image of the triangle ABC under this stretch. The y-coordinates are not changed. Stretch with invariant x-axis. Similarly, a stretch with scale factor k parallel to the y-axis leaves the x-axis unchanged, and the transformation matrix is given by. When multiplying by this matrix, the y-coordinate is enlarged by a factor of k, whilst the x-coordinate is unchanged. Let's see how it works. We take the transformation matrix and left multiply it by the shape matrix of triangle ABC to get the image of the triangle ABC under this stretch. The x-coordinates are not changed.